Offline policy evaluation in advertising marketplaces has a fatal flaw. Replay tables lie. When testing a new reserve price on historical logs, a policy might look like a revenue winner, but that lift could rest on thin air near the bidding threshold, masked by multiple comparisons or hiding subgroup harm. Point estimate rankings simply aren't enough. A recent framework flips this by treating offline evaluation as a decision support problem. Instead of a single winner, it outputs a conservative decision object. Certified policies, statistically dominated alternatives, and unresolved candidates requiring live testing. First, it abandons global metrics for support-localized generalization. By fixing a target boundary mass Q, it measures how tightly historical bid floor gaps cluster around the reserve threshold. If collecting evidence requires a wide neighborhood, the theoretical guarantee loosens accordingly. Second, it establishes an information-theoretic threshold resolution limit. Policies separated by tiny floor changes are statistically indistinguishable unless the effective boundary sample size crosses a hard barrier. Large logs don't save you if your decision boundary is sparse. Third, it replaces point estimates with simultaneous lower bound ranking. It builds a regret-tolerant shortlist by comparing every policy's upper confidence bound against the leader's lower bound. You only eliminate a policy if its optimistic value falls below the conservative benchmark by a certified margin. Finally, it certifies segment-level non-harm using Lipschitz continuity over a coverage grid, ensuring aggregate gains don't mask advertiser or exchange damage. Tested on iPinYou real-time bidding logs, this pipeline reduced a 19-policy catalog to a 2-policy shortlist. One policy was certified with a 40% simultaneous lower bound lift. Another remained unresolved due to strong local threshold efficiency, and 17 were eliminated with certified regret. Out-of-time replay confirmed stability. The takeaway is clear. Offline screening must produce certified validation decisions, not false confidence. By explicitly modeling threshold support, multiplicity, and response uncertainty, we build safer policy learning loops. Dive into the finite catalog guarantees and open-source code to see the full mathematical derivation.